Hey guys, today what I have for you is actually the day 3 notes, which is just some extra practice converting between the two forms, as well as the task of plane that you can't fly. And it relates back to some stuff with Harry Potter. So if you're a Harry Potter fan, hang tight. Here we go. All right, so in our day 3 notes, we start with a warm up, just again, going back and forth between polar form or trig form and complex standard rectangular form. So you'll notice our first two are in abbreviated trig form. So we know our modulus, our R value, and we also know our theta, our angle. So remember, to determine our A, which is the same as X, we're going to take R times cosine of theta, and to determine the coefficient of the imaginary, so I'm trying to get it to be A plus BI, that is the same thing as R times sine of theta. So for our A value, we are going to take 3 and multiply it by cosine of 350, which is approximately 2.95. And then we're going to take our B value, and that will be 3 multiplied by sine of 350, approximately negative 0.52. So our complex number for this example would be 2.95 minus 0.52i. There you go. I think we did that in our practice the other day. Pretty sure we did do both of these problems. All right, so we have z is 6 cosine I sine of 120. R value is 6. Theta is 120. Follow the same format for A and B. So our A is going to be 6 times cosine of 120, which equals negative 3. And our B value is going to be 6 multiplied by sine of 120, which is 3 square root 3. So when we write this one, we are in quadrant 2 based upon that angle. That's why our X value is negative. So our number in complex form or standard form is negative 3 plus 3i square root 3. And I prefer the answers like that. If you give me the decimal answer, again, not going to super stress about it. To put our stuff into polar form or trig form, remember in this case, we need to have our R value, our modulus, and then cosine I sine of theta. And sometimes your theta is the answer you get depending on the quadrant you're in. Sometimes we actually do tangent inverse and find the reference angle and work backwards from there. Example 3, negative 2 minus 3i. The R value is going to be the square root of 2 squared plus 3 squared, which gives us a square root of 13. And then to find our theta value, okay, so make note of where we are. We have both negatives. So we're actually down here in quadrant 3. So we're really going to be finding this reference angle first. So our reference angle, we're going to use tangent inverse of B over A. They're both negative. So a negative over negative is a positive. And when we get the reference angle, we'll use the positive value of 56 degrees. Now remember, theta is in quadrant 3, so I have to do 180 plus the reference angle. So our theta that we're going to use is actually 236. You have everything that you need to write R cosine I sine theta. So our R value is the square root of 13, cosine I sine 236 degrees. That is our answer for example 3. And then in number 4, our real number is 10. Our imaginary is 1i, or just 1 for that B. So there's my A and my B values. This is going to put us in quadrant 1. Yay, thank goodness for quadrant 1. So the angle that we find is actually going to be our theta. We don't have to use a reference angle. Okay, the modulus, the R value, is the square root of 10 squared plus 1 squared. So that would give us the square root of 101. And our theta in this case is, in quadrant 1, going to be the ratio tangent inverse of the y over the x, or the b over the a. So tangent inverse of 1/10 is teeny tiny, 5.7 degrees. So our final solution in trig form, r cosine I sine theta, gives us square root of 101 CIS 5.7 degrees. Good job. In this set, I'm not going to do each of these examples. I'm just going to pick a couple of them and walk through a few. You guys can practice the others and check your answers online. So I'm just going to go ahead and start with, let's do number 7. Why not? So we are in trig form or polar form, and I want to convert to complex number with exact answers. That means these answers are going to be on the unit circle. So you got to remember all of your stuff around the unit circle. All right, so in example 7, we have 3/2 as our R value. Theta is 300 degrees. Okay, so let's see, we need to find our A and our B values. A is R cosine of theta, and B is R sine of theta. So my A value is going to be 3/2 times, what's cosine of 300 degrees? That's an exact value on the unit circle. At 300 degrees, your Y value, your X value is 1/2. So A is 3/2 multiplied by 1/2, which is 3/4. Our B value is going to be R 3/2 times sine of theta, or sine of 300 degrees. And sine of 300 degrees in quadrant 4 is going to be negative. So we're going to have 3/2 multiplied by negative square root 3 over 2. And this will give us a value of negative 3 square root 3 all over 4. Okay, to put that back into standard form or rectangular form, we're going to write the real number first, 3/4, minus the imaginary 3i square root 3 all over 4. Now, if you want to write one big, giant, ugly fraction, you can put it all over 4. I just keep them separated. And let's go with, we'll do number 9 next. And you guys can do 5, 6, 8, and 10 and check your work. So we have our R value of 5. We have theta of 210. That is in quadrant 3. So both X and Y are negative. Keep that in mind as we go through. Our A value is R cosine of theta. Our B value is R sine of theta. So back to determining the real. R multiplied by cosine of 210 would give us 5 multiplied by cosine of 210 is negative square root 3 over 2. So that will give us negative 5 square root 3 all over 2 for the real number, real portion. The imaginary, our B, is going to be R multiplied by sine of 210. So 5 multiplied by sine of 210. And sine of 210 is negative 1/2. So 5 times negative 1/2 is negative 5/2. Okay, so R cosine of 210 plus I sine of 210 actually simplifies or converts into negative 5 square root 3 over 2 minus 5i over 2. That is the complex, standard, or rectangular form for that particular one. Great job. All right, so again, you guys have got the other 4 to practice on your own, and you can check your solutions online as you're going through. Let's get on with the task. Our first part is to plot and label the complex numbers on the complex plane. And so remember what each quadrant they go into. Remember that your x-axis is your real, and your y-axis is represented for the imaginaries. So P is going to be 4, negative 3i. There's P. I'll pick a different color for each. Q is going to be negative 2, 5i. So that's going to put us in quadrant 2 for Q. And R is 3 plus I. So positive 3 up 1 would be R. And again, if you want to draw these as vectors, you can. So we'll do that next. Well, actually, I'll just continue on. S is -2. That is only -2 on the x-axis. That is a real. And T is -I. -I is going to be down 1 on the imaginary. So here are the little vectors if you want to go through and sketch those as well, all from the origin. And they do represent the ordered pairs that we have sketched. All right, there's my Q. I got one more to sketch in here. And P from the origin down to 4, -3i. There you go. Good job. Piece of cake. You will have to do that on a quiz, so just be mindful. So we're using the notation, the absolute value of Z, to represent the modulus. And remember, the modulus is the same thing as your distance, and that would be from 0, or you could think about it from the origin if you're going through. All right, how is this related to the idea of the modulus of a complex number? So absolute values are distance from 0. So remember, the magnitude equaled the distance of the vectors, okay? And the vectors have an initial point of 0, 0. If we're putting it into complex, it would be 0, 0i. So the modulus and the magnitude are basically the same. So the magnitude, or in this case, make sure you're using the correct word, modulus, is in fact the distance from 0 or from your origin, okay? And then practice with finding the modulus for each of these. Remember, this is the square root of a squared plus b squared. Your horizontal is always a, your vertical is always b. So for P, for -3i, we have the square root of 4 squared plus 3 squared. And you'll notice I dropped my negatives for these because you're squaring each of the terms, finding their sum, and then taking the square root. So when you square them, you're always going to get a positive. That'll give us the square root of 25, which is 5. Piece of cake. Q is the square root of 2 squared plus 5 squared, which is just the square root of 29. R is the square root of 3 squared plus 1 squared, which simplifies to the square root of 10. For S, we have the square root of 2 squared plus 0 squared, because I don't have an imaginary. So that's just the square root of 2 squared. Square root of 4 is just 2, like that one. And for our last one, we only have an imaginary, so it would be 0 minus 1i, if you'd like to see it written that way. So its modulus, or its R value, is going to be 0 squared plus 1 squared. Square root of 1 is just 1. There you go. And remember, as we're talking through, the modulus and the magnitude go together, and a direction angle is equivalent to an argument for our complex numbers. And again, we're staying within that range, 0 to 360 or 0 to 2 pi. So in our next part, we're going to determine the argument. Remember, it's always a plus or minus bi. A is the same as our x or our cosine. Y is the same as our b value, which is sine. So we're going to use tangent inverse of the b over the a. So the first one would be tangent inverse of -3/4, which gives us -37 degrees. We're going to use that as a reference angle and determine what quadrant we're in. So if we have the point 4, -3i, that's quadrant 4. So in quadrant 4, I need to take 360 minus the reference angle in order to determine theta. So 360 minus 37 gives us about 323 degrees. Whoopsies. 323 degrees. That is our theta for our first example. Okay, for point Q, we have tangent inverse of the B over the A, 5 over -2. Okay, remember this one, -2 plus 5i puts us in quadrant 2. That helps us as we go through. So tangent inverse of -5/2 gives us -68 degrees. So quadrant 2 is 180 minus the reference angle to get theta. So 180 minus 68, remember we're always using the absolute value or positive of our reference angle, gives us about 112 degrees for our point Q. I think you guys get the gist of this. It's not too bad. And I'm just going to put the answers down so you can kind of work through a few on your own and check them. Point R, 3 plus I, is going to be in quadrant 1. So that is going to be the answer that you get. You don't have any extra work. It's just tangent inverse of 1 from the I over 3, which does give you just about 18 degrees, all done. Our next one, S, was actually on the x-axis. So that will give you a value that lands on the x-axis, and T was a point that was just on the y-axis. So that will give us a value only on the y-axis. Okay. I'll let you guys try those and see how you do with them. Check your answers online. You got it. All right, here we go. Now we're going back into Harry Potter world. So again, using the modulus and argument, converting between the forms of rectangular and trig, or you can use the shorthand if you choose. We are going to show different ways to do these. Okay, so Harry walks 4 miles west and 6 miles north. What path would Hedgewood take? Okay, so if I go 4 miles west and 6 miles north, the path that we're taking puts us into quadrant 2, and we would have the ordered pair or the number 4 plus 6i. That would be the value in complex form. Okay, in order to determine the r value, so I'm looking for this radius, r is going to be the square root of 4 squared plus 6 squared. So r is our square root 16, and 36 is 52. And 52 simplifies to give us, let's see, that's 52, put that there. That simplifies to be 4 root 13, so that'd be 2 square root 13. Okay, so that's our r value. We are in quadrant 2. So in quadrant 2, we're actually going to first find a reference angle. And our reference angle is going to be tangent inverse of the b over the a, or y over x, sine over cosine. So tangent inverse of -3/2 is about -56 degrees. We are going to use that value to help us get theta. Quadrant 2 is 180 minus your reference angle. So 180 minus 56 degrees gives us 124 degrees. So we need to use 124 degrees and the r value that we found at 2 root 13 to put this into, from complex into trig form. And I'm going to go ahead and abbreviate it, and I'm going to write it as 2 square root 13 cosine I sine of 124 degrees. If you changed to root 13, you'd have approximately 7.2 cosine I sine of 124 degrees. They both mean the same. Okay. Our next one is doing the same thing, but in reverse order. So now we have Hedwig. He's flying 2 miles at an angle of 210 degrees. All right, so where's 210 degrees? Down in quadrant 3. And he's flying 2 miles. So that is this distance. That's our r value. And our theta is 210. Remember, we do want to use our reference angle right here to help us. So the reference angle is this guy. And if we're 180, We go past that. 210 minus 180 gives us 30 for the reference angle. There you go. We're determining our x and our y values. And remember, in this quadrant, we'll have a negative x and a negative y as our ordered pair. All right, so to find our x and y, or the a and the b values, a equals our cosine of theta, which will be 2 multiplied by cosine of, you can actually use 210 if you want. That way you don't have to worry about the sign. It'll give it to you perfectly. And it simplifies to be 2 multiplied by negative root 3 over 2, which just gives us a negative square root of 3 for the a. For our b value, we're going to do b is our sine of theta. So that'll be 2 sine of 210. Again, because you can go back and forth with using reference angles and changing signs, or just using your given angle. It means the same. Sine of 210 is negative 1/2. So 2 multiplied by negative 1/2 simplifies to give us negative 1. So our point in complex form is negative square root 3 minus 1i, or negative 1.73 minus 1i if you want to see that. And what directions did we travel? We went west 1.73 miles, and then we went south, because that's negative 1 mile. So that's how you would turn that back into, from complex or standard form, into actually what it means within this particular example. All right, and number 6, Harry's directions are written in component form of a vector, which is like rectangular form. And 7, Hedwig's are written in magnitude direction form, which is very similar to trig form. And it says go back and forth and put them from standard form into trig form. We've actually already done that. We have those values. We just have them in shorthand. So there's no reason to go back and do that again. So you can skip number 8. Yay for skipping number 8. Number 9, each of these different points, you're practicing that same information over again. I'm just going to pick 2 of these and we're going to roll through them. So how about we'll do S and T this time, because I did the other ones the last time. So if these are in complex form, I want to put them in trig form. So the R value for S was 2, and your theta should have been 180 degrees. I hope you got that right when you practice that one on your own. So in trig form, it's R cosine of theta plus I sine of theta. So I'll have 2 multiplied by cosine of 180 plus I sine of 180 degrees. Or if you like to abbreviate, 2 cosine I sine 180 degrees. Love each of those. In examples 4 and 5, when we had to do the point for t, and for t, we got the R value to be 1. And then in example 5, hopefully you realized that our theta would actually be 270 degrees, because we're going to do, this was tangent inverse of negative 1 over 0, which is undefined, and tangent is undefined at 270. Okay, so again, our point T, that's in complex form, negative I, converts to R multiplied by cosine, of 270 plus I sine of 270, which turns out to be very, very simply, excuse me, not 1, my goodness, 1, you could put it there if you want to, cosine I sine 270. There we go. Again, you don't have to have that 1 that's in the front. Don't have to at all. All right, our last little chunk of this, number 10, we have new examples so that we can convert from polar trig form into complex or standard or rectangular. And there's a typo in your notes up there. All right, Again, I'm just going to pick a few of these. So we'll do, let's do V and W. I'll let you guys check the others on your own. So for V, we have 8 cosine I sine of 135 degrees. 135 degrees is quadrant 2. So if I do a little teeny tiny rough sketch, quadrant 2, my R value, the modulus is 8, and I have 135 degrees that I have traveled around from the positive x-axis over. So I need to determine my reference angle. So quadrant 2 is 180 minus the 135 to give me the reference angle of, anybody got it? Hopefully 55 degrees. There we go. That is one way to do it. You can also just use the, you can just use your angle of 135, whichever way you like better. So our A value, the horizontal, works out to be R times cosine of theta, and cosine of 135 degrees is the square root of 2 over 2, but it needs to be negative because I'm in quadrant 2. And this simplifies to give me -4 multiplied by square root of 2. Our B value is going to be 8 sine of 135, or you could use your reference angle. Oh, I totally did my reference angle wrong. That should have been, goodness, excuse me, guys. Big mistake there. Quadrant 2, 180 minus 135 would be 45. Goodness. All right, so back to B, sorry. B is R times sine of theta, and sine of 135 is positive square root 2 over 2. So we get +4 square root 2. All right, so for for V in quadrant 2, complex form, standard form, rectangular form is -4 square root 2 plus 4i square root 2. Now, it really doesn't matter where you put the I, whether it's in the front of the 4, the back of the square root. I usually kind of try to tuck it in between. Means the same thing. All right, let's take the shortcut for W. W is 3 cosine I sine of 350. Oh, goodness, we've already done this one with 350 a couple of times. So in this case, we are in quadrant 4. If you wanted to find your reference angle, it would be 360 minus 350, which gives you 10. But in that case, you've got to remember what's positive and what's negative in quadrant 4. To find our A value, it is the R value, 3 multiplied by cosine of theta. 3 multiplied by cosine of 350 is approximately 2.95. I feel like we've done this problem a million times. Our B value is the imaginary, 3 multiplied by sine of 350, which is approximately -0.52. So our point, our number in complex form will be 2.95 minus 0.52i. I know we've seen that problem before. All right, you've got a few more of those that you can practice on your own. You also have worksheet C as another really great extra practice to make sure that you're good for everything for your quiz. Remember, you are going to have to do some addition, subtraction, multiplication, and division of just complex numbers. So make sure that you look at worksheet A as well, because it's got that review from Algebra 2 as well. Hopefully you guys have a great day. Make sure that you have your questions ready for me when we get back before you take your quiz. See you later, guys.